Welcome back to the Future of Investing. I'm here in the Metropolitan Club in Manhattan at the Global Creative Leadership Summit, where I'm going to be talking to Benoit Mandelbrot, who is, in many people's opinion, a genius. He's a mathematician, now well into his 80s, who was born in Poland, spent the war in France, and then came here to the US. He's best known as the inventor of fractal geometry, but he is now perhaps most relevant to us because he was also the first and most prescient critic of the theory of efficient markets, which led to the very complicated investment products that crashed disastrously in the last 2 years, causing the crisis. He was much criticized for his ideas about markets when he first produced them, more than 40 years ago now, but in the last few years many people are beginning to think that he was right all along. That means that his views on the future of investing are particularly interesting. Let's talk to him now. Professor Mandelbrot, thank you very much for being with us here today.
Thank you very much for inviting me.
Let's start, if you could explain where the efficient markets hypothesis comes from, where it intellectually started, and what it presupposes.
Well, it started precisely in the year 1900, when a man named Bachelier, a French mathematician, presented his PhD dissertation called The Theory of Speculation. It's a remarkable piece of work which has had an enormous influence on theory of probability, enormous influence on what's called Brownian motion. But it was meant to be a theory of the way in which prices vary on markets of securities, of commodities, etc. As such, it had the most bizarre history. For 60 years, hardly anybody paid attention. 6 years later, when the computer became available, when people could really compare that theory with data, the Bachelier theory suddenly became known, people became aware of it, and it began to rule the roost of those who were trying to model the variation of prices on the various exchanges.
And what exactly does the Bachelier theory suppose or posit about the way that markets work?
Well, it posits markets work in an extremely simple fashion. As a matter of fact, it posits that markets are simpler than most physical phenomena, which is quite extraordinary, strong assumption. It posits that, in a certain sense, price goes up or down by a toss of a coin. If it's heads, the price goes up a little bit. If it's tails, it goes down a little bit, and just goes on like that endlessly. If you buy when the price is high, well, you lose. If you buy when price is low, you gain. But it's a model of extreme simplicity, which has, in a certain sense, no parameters. If you scale the time appropriately and the value appropriately, it's the same theory for everything.
So it's a complete random walk, and the chance of a big move on the stock market is the same as the chance of the same coin coming up heads 20 times in a row, for example.
Yes,
that kind of idea.
And the chance of a sharp discontinuity is zero, because the process is assumed to be continuous. Price varies continuously by amounts which, of course, in reality, one doesn't have the continuous change because one has finite number of readings, but the theory says price varies continuously in continuous time.
Right, and remembering the day early in 2007 when the Dow Jones Industrial Average fell 200 points in 1 minute, that already begins to sound as though it's not a very accurate portrayal of the way markets actually work. Had he actually done empirical work on markets, or was this a theory based on assumptions?
Well, Bachelier did not mention any experiments. Rumor is that he had done some experiments, but they are not reported. He has written about it in other papers of his, but one knows very little about him. He is a kind of mystery man in history of mathematics. He was presented PhD, got the doctorate, and disappeared for quite a while, until much later became professor of mathematics in the provinces. One does not know his motivation very well.
Now, why do you think he appealed to this generation of financial economists who came along in the 1950s and 1960s and came up with all the ideas that undergirded derivatives and the complicated products that we all got to know about last year?
Well, I was present at that time. I was close to that field. The reason was that the computer came, many things could be actually done, tested, data became available, and one was, in a certain sense, was a thirst for existing theories that might help. And here, miracle of miracles, in 1900, a complete theory was discovered, rediscovered in libraries, and one could have already a history. One could pick out of Bachelier all kinds of formulas which answered questions which people were asking themselves.
Now, as I understand it, the Bachelier theory implies that returns follow what we all commonly know as the bell curve, that most things will be clustered in the middle and there'll be just a few wider movements at either end of the scale. What did your research tell you once you started taking a look at this, which is what, in the early 1960s, I believe?
That the tails in question, which are so completely impossible to draw because they are so thin, just a few events, the tails are extremely long. And that a record one looks at can seem to be just small steps up and down, and then one gigantic step. And the gigantic step itself is very often, in a certain sense, segregated. Market stops trading. Trading stops and then it resumes at a different value. The question arises, do you take this big, enormous jump as part of the process, or do you say it's an act of God depending upon different rules? If you say it's an act of God, it fits in Bachelier if you wish, because you have put all the big events under the carpet.
But those big events are actually what matters most about markets, aren't they?
Absolutely.
So what was your alternative idea that you were putting forward 4 decades ago, and why do you think it was not taken more seriously when it came to drawing up the way in which we invest?
Well, more than 4 decades ago. Right. It made quite a sensation. It was criticized before it was published, which is a compliment which one doesn't want to have, but which is indicates what happened. My theory was based upon, first of all, an observation, which I made accidentally. I was coming to give a lecture at Harvard, as a matter of fact, and on the board of my host I saw a certain drawing which I was going to use in my lecture. So I asked my host, but how come you have on your blackboard the drawing I'm going to use? He says, I had no idea what you're going to say, but this thing refers to price change and refers to the distribution of one price change and next one, the joint distribution. It turns out, for technical reasons which I cannot explain here, that there are 2 different shapes of this distribution, one which goes this way, one which goes this way, and of course you can go in between. Everybody was assuming it was that way.
Right.
What I saw on the blackboard was this way. In other words, the data were presented to me ideal fashion by pure chance. And I asked this chairman, who became my friend, to give me his cards. I went home to where I was working at IBM and analyzed this data and found that this distribution, as I had inferred for my own reasons, represented a situation in which the large price changes, even though few, were so large as to be the most important thing there is.
So that's utterly contrary to Bachelier, in other words. And
my work was very soon criticized, quite sharply, of course, and but the main critic, who wrote a very nicely written story, says that, well, we have known that there were these big values, but since we didn't know what to do with them, we just swept them under the carpet.
So if you're trying to model risk management, and that's the main use that efficient market theory has been put to, is managing risk, they're admitting from the start that they're not trying to take account of the biggest risks when managing risk.
Well, that person did state it very clearly in a critique of my work in a book that he edited in 1963 or 64.
And why do you think that the theory became so popular? Is it because it made investing look easier than it was, that it made the world look simpler than it was, or what lies behind it?
Certainly the word simpler than it was. The reference to Bachelier in terms of influence was not there. I mean, the work would have occurred anyhow. But the theory of Bachelier had become very important as the Brownian motion. And there were books and books and books about it. Many people knew about it. Therefore, there was a certain capital of knowledge, capital of wisdom, which was available and one could draw upon. And on one hand. On the other hand, my work had one, two references, very obscure, not very close to what we're looking at. In a certain sense, my work promised, well, great amount of work and trouble and effort. And the other promised a capital on which one could live for a while.
So in some sense this is down to academic politics, that if efficient markets were true, then we can build a lot of theories from it, and if your theory is true, then we have to work a very long time and we may not find anything that we can use at the end of the work.
Well, it's an extreme version of what I think happened, yes.